All right, so what we have here is now we're going to start looking at transformations of functions. And so we're essentially just going to shift functions around and just kind of manipulate them from a basic idea of a few different functions. And we're going to kind of move them around and get a whole then just bunches of families of functions. That we have is what is called a constant function. It will look something like this. F of x equals some number c, where that number c there is a constant. So this could be like f of x equals 7 or f of x equals 4, or we can do an example here, f of x equals 3, like that. That would be f of x equals 3. And they are horizontal lines just like that. So that's what you need them to look like. I can get a straighter line on there if I use that little tool. There we go. Okay. And so you get something like that. The next one is called the identity function. This is anytime you have a function that's f of x equals x. In other words, whatever you put in is what you get back out. So if I plug in 7, I get a 7. If I plug in 4, I get a 4. So if I plug in 0, I get a 0. If I plug in 1, I get a 1. If I plug in 5, I get a 5. If I plug in -4, I get a -4. So you get all these points as you go through there, just like that. And so what you end up with is that right there. And that is the identity function, essentially just f of x equals x or y equals x. All right. The next one is the absolute value function. And this is the function f of x equals the absolute value of x, like that. And for this one, whatever number you plug in, you're just going to get the positive version of it. So if you plug in 0, you get 0. If you plug in +2, you get +2. But if you plug in -2, you also get +2, like that. And so what you end up with is a V-shaped graph like this, where it's very similar to, that last line didn't go very well, very similar to the f of x. That one didn't go well either. The f of x equals x, the identity function, is just, it's almost like when it gets down to the origin, it bounces off of it rather than just continuing on down at an angle. So they're the same over here and over here, but it's like this part just got flipped up, like it came down and bounced off. And that's really the difference between those two. They're otherwise very similar. The next is a quadratic function. All right, this is f of x equals an x squared type of graph. Every time you plug in for x, you have to get an output of that value squared. And so you plug 0, 0 squared is 0. You plug in 1, 1 squared is also 1. And you plug in 2, and 2 squared is 4. Plug in 3, and 3 squared is 9. And it goes something like that. And then on the negative side, if you plug in -1, -1 times -1, we get a +1. -2 times -2 is +4. And so you get the same kind of values, but mirror imaged on the other side. And so what you end up with is this kind of U-shaped graph. I don't know why I got that a little bit right there. But this kind of U-shaped graph, it's not V-shaped, but it's kind of U-shaped down there at the bottom, and a graph kind of like that. I didn't do a very good job on this second part, but there you go, something like that. It's kind of U-shaped, definitely down here at the bottom. It's not going in like a straight V, but curved down there at the bottom. So just be careful of that. Sometimes they look so pointed, they're so narrow that they look kind of pointed, but it's curved. All right, and so that's your quadratic function. The next one is a square root function. Is a square root function. This is f of x equals the square root of x, like that. For this one, the only way that we can be, the way we get this one is essentially it's that same parabola, but turned on its side and then only half of it. So if you plug in 0, you get 0. If you plug in 1, you get the square root of 1. You plug in 4, you know, you get the square root of 4 is 2 and so on and so forth. And so it looks like that previous one just turned on its side and only half of it. So it's like half of the parabola from that quadratic one like that. Okay, we can't include the bottom half over here because then we'd fail the vertical line test and it wouldn't be a function. So we don't include the plus or minus on that one. It's just the square root of x. Last one here on this page is f of x equals x cubed. So this is a cubic function. For this one, because we have that odd exponent, if we plug in negative numbers, they're not going to turn out to be positive. So you plug in some things like 0, 0, you get that. You plug in 1, 1 cubed is 1. Plug in 2, 2 cubed is 8. So you put you up here. And so on this side, you get something that kind of looks like this. And it kind of looks similar to that quadratic one above it. But when you go to the negative side, -1 times -1 times -1, so -1 cubed is actually still -1. And -2 cubed is -2 times -2 is -2 is actually -8. So that puts us down here. So it does something like that on this side, okay? And is actually an odd function. All right, so I'm going to go ahead and pause right there and see if there are any questions before we move on. So one moment, please. All right, so like I was saying, make sure you get these memorized. You really, 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 really want to know them or you're going to struggle moving forward. So make sure you know these. All right, so next we're going to start taking a look at how we can just move these things around. The first one we have is vertical shifts. You can see that we have the function f of x equals x squared plus some value c right there. That c value is a constant that we are adding on to every single result. So essentially it's like we're taking our function f of x equals x squared, getting that result, and then just adding some value onto it. This has the effect of shifting our graph up by c. The next one is the same sort of thing, except we're subtracting. And so this is going to shift our graph down by c. All right, it's going to shift it down by an amount c. And then we have a couple of examples here. Here we have just in the picture, that's the graph of y equals, or f of x equals x squared. So this is f of x equals x squared there in blue. And so what I'll do in green is I'll do x squared plus 3. So if you think about this, this is actually equal to f of x plus 3, right? We're just taking that and adding 3 onto it because f of x was x squared. And so whatever value I got from f of x, my x squared, I'm just going to add 3 to it. So I'm going to come to this graph to every single point, and I'm just going to go up 1, 2, 3, put a point. Go over here, up 1, 2, 3, put a point. Just like that, 1, 2, 3, put a point. Everywhere you do this, you'll get a new value for it. So just come along here. I'm not going to draw all those out, but point, just like this. And you put points in there, and you can go through and actually then graph out the resultant function, which is the same parabola, but shifted up by 3 like that. All right, so just like that, there is the g of x function, g of x right there. Okay, for h of x, I'll do that one in red. That is just simply going to equal f of x, whatever our values were from f of x, minus 2. So we're going to move that one down 2. So you go to every point, you drop down 2, down 2, down 2. So I'm just dropping like that point, just dropping down 2 like that. And then I come up here to this point and I drop down 2, and this point and I drop down 2, and this point and I drop down 2 like this. And I just go along to any point that I can and I drop it down by 2, and you end up with this function here, this curve, which is again that parabola, but shifted down by 2. And that one is h of x right there. So this one was down 2. This one was up 3. All right, that is vertical shifts by adding or subtracting to the overall result of our function. All right, so that's vertical shifts. It's not too bad. But now horizontal shifts, they get a little trickier. Notice now we're adding a constant value not onto the overall result of the function, like we did up here, where we had the overall function x squared and we added something on to the outside of it after we did the squaring. Here, what's happening is we are actually adding a value inside the function onto the value we're inputting. So if we try to tell it, here is a 0. So I give it my input value, I give it a 0. What it first does is adds a value of c onto it and then plugs it into the function and then does the squaring. So as a result, these shifts end up acting a little different and they do the opposite of what is there. So if I have an x plus c, this time what it is going to do is shift the graph in the negative direction. Left is the negative direction in the x direction, and it's going to shift it left by c. And if I have a minus, it's going to shift it in the positive direction. So it's going to shift it right or positive by an amount c, right there, just like that. Okay, so whenever you're doing something inside the function itself, whenever you're doing it directly onto the input variable, it's going to do the opposite of whatever is there. Whenever you do it after you do the function, when you do it to the whole function like we did above, it's going to do exactly what it says. Doing it inside the function directly on the x, it does the opposite. So again, we start here with the graph f of x equals x squared. So this is that f of x function, same function. But now what we're doing is we're subtracting 2 from inside of it. All right, and so that's this first one here. I'll do that one in green. This is going to shift it to the right by 2. So this is going to shift right 2. And so that means every point here, I'm going to take and shift over to the right by an amount 2, like that. And every point that's going to happen, shift them all over by 2. And when I do that, I get all these points in here. And then I get my shifted graph here. That's a point. All these are points. And you end up with this parabola that's shifted. It's the same parabola, but shifted to the right. And that is g of x, shifted off to the right by 2. If you look at the next one, I'll do that one in red, it's going to shift left 4. Because we're doing the opposite of that plus symbol since it's happening directly on there. Because whatever we're doing, like say we plug in 0, what really gets squared is not 0, as it would have in the original f of x equals x squared. We would have squared 0 and gotten 0. But now what we're squaring is 4. And when we square 4, we're way over here. And it's this point way up here that would be like 16. That would be like way up here. But we're shifting that back over where we plugged in 0 for x. And so that's why it shifts in that opposite direction. So the result we get from giving it 0 is actually the result we would have gotten from the original graph had we plugged in 4. So that moves everything back over 1, 2, 3, 4 over to here. And then we just redraw that same parabola like that, just shift it over. I don't have to shift every point. I just know that once I get there, same parabola, right? And I just plug it in and I get my shifted over parabola. And this is h of x right there. I didn't do that very well. Let me rewrite that. This is h of x right there in red. Okay, shifted to the left by 4. All right, let's see if there are any questions on. All right, so here we have some examples and we're going to go ahead and try them. Now, this works for any of those graphs we did on that first page. It doesn't just have to be that x squared we were just doing. So let's take a look at this one. f of x equals the absolute value of x. I'm going to do that one here in green. So I'll put a green star. So f of x will be in green, and that is simply this V-shaped graph like that. All right, there's f of x. And then I'm going to do the shifted one in blue. So I'll put a blue star by it. That is going to be g of x equals the absolute value of x plus 5. Now, the plus 5 is occurring after we take the absolute value. So it's essentially this. It is f of x plus 5. It's outside the original function being the absolute value of x. And being able to identify your original starter function is very important for being able to do these. And so when I do this, I have to then move this up vertically by 5. So that takes all of my points, moves them up by 5, right? Straight up by 5. And I'm going to just redraw that same V with the same slopes, shifted up by 5, just like that. And so that then is my g of x right there. So we had our f of x and our g of x. I should put some arrows on these. Okay. So then let me do this other one right here. So we're going to try this one. Again, I'll do the first one in green. F of x equals x cubed. So remembering what that graph looked like, it went through these 3 points and then the point 2, 8 and -2, -8 like that. And so the original function looks like this. All right, there's our original f of x function. But on this one, we essentially have here, let me erase that, I put that in the way. This is f of x here in green. This is essentially f of x minus 4. All right, that's what that is. We're doing the -4 inside of the x cubed function. And so what that does is it's going to shift us to the right by 4. It's because we're going to end up doing the opposite now since we're making this change inside the function. So it's going to take all our points, shift them over by 4. So we can just take one point, shift it over by 4, and then redraw the function right there. So we can start there, 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 and then this down here and over 1 and up 8 again, just like that, and redraw this same function like this. And there you go. And there is that function shifted to the right by 4 because of the change we were doing, again, was taking place inside the function. The first one is outside the function, so it's a vertical shift that does exactly what is there. The second one there is happening inside the function, so it does a horizontal shift in the opposite of what is there. So it's a -4, so we do a +4 shift. What I want you to do is try these two, but notice if you look at this one, you've got both a shift occurring inside the function, right? The function being x square root of x, and you have a shift occurring outside the function there. So see if you can figure out what to do with both of those shifts combined into one and see if you can get that graph. All right, so give that a try. All right, so for this one, let's take a look here at number 3. We're actually going to have 2 shifts that occur. So we could actually rewrite this function as we can do f of x plus 2 and then a -1, just like that. So what we're doing is we have a +2 inside, so that's going to shift us horizontally in the opposite direction of what's there. And then we have this -1 outside the function that's happening after it comes out of our function machine, and therefore that's going to shift us vertically. So the first thing I want to do is, what did I do the colors up here? I did green for the first one. Oops. And then I did blue for the second one. So let's do green for this one. This will be our original function, square root of x. Our key points there, 0, 0, 1, 1, and then 4, 2. are some key ones there. And then of course, we can go from there. And then of course, 9, 3 is a point as well. But there you go, that's our original function. And so what we're going to want to do, and it doesn't matter which order we do this in, we can shift left 2. So this is going to tell us left 2. This is going to tell us down 1. It doesn't really matter which order I do those in. So I'm going to go left 2, down 1, just like that. And I'm going to redo my graph right there, starting at that point right there. So let me get these little lines out of the way, but I'm starting right there. So I can go through and do each point, left 2, down 1, left 2, down 1, or like that. Or I can just redraw the same picture. I knew here I went up 1 over 1 and up 2 over 4. So I'm just going to do that same thing. Up 1 over 1 there, up 2 over 4 to right there. And then I can draw my basic curve in like that. And there is g of x. And this green one was our f of x. Okay. And so there is that one shifted. This other one, I'm not going to go through and do the whole thing, but what you should have had is a horizontal shift in the +3 direction, and then a vertical shift up 2. So that's over 3 up 2, and that puts our parabola right there, over 3 up 2, and then just redraw our standard parabola right there with these key main points like that. 2, 4. All right, just like that. And there you go. That's the answer you should have gotten for that one. Left, or I'm sorry, right 3, right 3, up 2, just like that. Okay. So let's see any questions on those two. All right, so for this one, we don't really have an actual equation that we're working with. We just simply have a given graph function, and this looks like it would be a piecewise function. This looks like an upside down parabola, and this looks like an absolute value or something like that going on. But that doesn't really matter. All we need to know is we're taking this original f of x function, which is given there in the picture, and we're doing this shift external to it, up 2. So all I'm going to do here for this one to regraph it is I'm simply going to move everything up 2. So I'm going to take some of these key points that I know for sure, and I'm going to just shift them all up by 2, just like that. And then I'm going to go through and redraw the graph. So I have this curvy part right here. That's that little upside down looking parabola. And then I have this V part right here that I'm going to redraw. And then of course, I'm going to fill in, just like that. These were those key points that I moved, and I got my graph shifted up by 2, right? This was up 2, just like that. Okay, so go ahead and take a look at this one and do this one on your own here. All right, so on that one, like we just said, it's inside the function, so that's a horizontal shift, and we do the opposite, so we shifted everything to the right by 2, and that's that green function there. Next, we can look at reflections of graphs, where we're going to start reflecting them over or about different axes. And so the first thing we can do is reflection over or about the x-axis. So reflecting about, or sometimes people say over / or over the x-axis. And so here we have f of x equals x squared. That's that same old square root function here we should be getting pretty good at by now. Let me zoom in a little on it. 1, 1, these points right here, just like that. 3 gives us the 9s like that. And so we have this here. I don't have to draw it perfect, but there we go. We have that x squared. But now when we look at this one, we have g of x equals negative x squared. And so notice this is a negative outside of the x squared. This is happening outside. So this is negative f of x, like that. And since it's happening outside of the function, our function being the x squared, this is going to affect the y values, which means it's going to change it vertically. So a reflection over or about the x-axis is actually a vertical reflection. And what that's going to do is flip our graph over this way, like that. It flips all of our over so that all of our y values become negative values, because we plug it in the machine, we plug in 2, it gets squared, it becomes this 4, and then we flip it over and make it negative 4, like that. And that's how we end up with going from 2, 4, and then we flip it down to negative like that, because it happens after it comes out of our function machine and it becomes that negative value. All right, so that one right there is a function that flips it over the x-axis. It's a vertical flip. All right, so it's outside, it's a vertical flip, if you want to think of it that way, a vertical flip across the x-axis outside of it. Now let's take a look at a reflection about the y-axis real quick here. Here's our function square root of x. That is this. It's this function right here, right? That kind of half of a sideways parabola is that one right there. But now what we're doing is we have this g of x here, and it's a negative inside of our function there. So this is actually g of negative, not g of negative x, f of negative x. I'll get it right. So this is actually happening inside on the x's. Therefore, we have to do this in the x direction, in the horizontal. So this is in the horizontal direction. So this is a horizontal. It's a horizontal flip. All right, is that what I said up there? Flip. Yep. So it's a horizontal flip, a reflection about the y-axis. And so what this does is basically every number we try to plug in, we're actually plugging in the negative of it. So if we try to give it 1, it doesn't take the square root of 1, it takes the square root of -1, which we can't do at this point yet here for these graphs. We have no imaginary stuff here. But if we plug in -1, it actually takes the square root of +1. So that ends up putting all of our values flipped around this way. And so it reflects it across that y-axis. So this one was a nice reflection across that y-axis, right? Whereas this one, which was a vertical flip, was a reflection across that x-axis, okay? Like a mirror image for the two of them right there. All right, I think that's pretty much it for the time for right now. So we're gonna have to stop right there.